Hello, Mark. Thanks for joining us today for this short webinar. My name is Mark Guthrie. I'm with Smart to Market, and I'll be the moderator for today's webinar entitled Virtually Plan and Validate Your Entire Manufacturing Assembly Process. Our speaker today is Mark Jablonski, and Mark is co-author of the book 3D Manufacturing Evolution. You'll all be receiving a PDF of that, and it's about how companies are extending the use of their 3D engineering models across their organizations. And like I say, we'll be sending you a PDF of that. Today's webinar will be 30 minutes long, and we'll have time for questions at the end. Please submit your questions in the GoToWebinar interface, and I'm going to post something right there that you should all see where that is. So as Mark's going along today, please submit your questions. We'll get to as many as we can at the end, and if we don't get to them, we'll respond offline. So now I would like to begin with a couple of polling questions, and if you could just respond, and then I'll share the results with people. So the first one is, what best describes your role in your organization? So we'll take just like 15 seconds for people to respond to that. Okay, I'm going to close it and share the results. So 50-50 product design and manufacturing, which is really what I would expect. So very good. Thanks for responding to that. And let's see, let's do one more poll. And this one is all about today. How do you validate your assembly plans currently? So I'll give people just a second. Okay, just a few more seconds here. And this was not surprising to me. And let's share the results. So 100, actually changed just at the very end. So at first it was 100% of people are using their CAD models, and then it changes at the very end. So using lightweight models, which we're going to talk about today, XBL is one of those that is from Lattice Technology. So a lot of people using their CAD models to do their validation. And with that, I would like to hand this over to Mark Jablonski. Go ahead and take it away.
Okay, thanks, Mark. And let's go ahead and get started here.
This presentation shows how you can use XBL to perform digital assembly validation. First, an overview of digital assembly validation. Starting with the digital prototype, you perform digital assembly validation by visualizing the assembly process, checking the assembly procedures for things like interferences, also checking the workability and the safety of the procedures, and creating issue reports. These reports are fed back to the design team, and as subsequent design revisions are produced, this process repeats until all of the major production issues are resolved and the model is released for production. The benefits of digital assembly validation include being able to start production planning early, that is, before you have a physical prototype to work with. Being able to easily identify issues with using the 3D visualization. And resolving the production issues in the design phase when the cost of resolution is much lower than later on. This results in better design, quality, and communication, and reduced costs and reduced lead time. Why use XBL for assembly validation? Well, as we just saw, traditional assembly validation requires a physical model, but XBL-based digital assembly validation can begin as soon as there is a digital model. Also, it's time-consuming to validate assemblies using physical models, but XBL-based digital validation includes rich tools to quickly find and report issues. In general, 3D data is large for effective assembly validation. But XPL data is lightweight, and it enables you to validate large models without sacrificing accuracy. And finally, previous validation cannot be used on new versions of the model. But XPL's AutoUpdate function enables you to import all your previous validation results into new versions of the model. Here's the workflow for digital assembly validation using XPL. You start by converting the CAD data into lightweight XPL. Then you can begin the digital assembly validation process. As mentioned before, there's no need to wait for a physical prototype. The first step is to visualize the assembly process by creating step-by-step process plans and animating the assembly paths. You can then use dynamic collision detection to check for interferences in the assembly paths. You can also use dynamic measurement to ensure proper clearances. You can then add tools and human models to check the workability, visibility, and safety of the assembly process. And when there are issues, you can document them using 2D and 3D snapshots, markups, and annotations. After completing your assembly validation, you can save the XPL file and automatically generate reports which are sent back to the design team. When there's a new version of the model, you can use XPL Studio's AutoUpdate function to automatically carry forward all the work you did in the previous version of the model. Step one is to visualize the assembly process by creating step-by-step process plans and animating the assembly path. Here's the model in XPL Studio. As you may know, XPL Studio makes it easy to author an assembly process. The first step is to define the MBOM, or manufacture tree. You can do this manually by dragging and dropping parts from the assembly tree, or EBOM. Or you can automatically initialize the MBOM as a copy of the EBOM. Once you've built the MBOM, you can hide the assembly tree since we won't be using it anymore. The next step is to define the assembly sequence. Again, you can do this piece by piece by manually dragging and dropping parts from one tree to the other. Or you can initialize the assembly sequence as a copy of the manufacture tree. After you've defined the assembly sequence, XPL Studio has tools to let you animate the assembly. By default, the parts just appear in their final position, like this. But XPL Studio has tools that allow you to easily alter the assembly path. For example, the mounting base, let's drop it in. You can simply drag it and set a keyframe. Drag again, set another keyframe. And now when you play, it drops into place. Let's take a look at the next part, tightening the mounting base here. The parts themselves are pretty hard to see, so let's go ahead and zoom in on them. And then maybe change our angle of view. Okay, once we've got it the way we like, we can just save a process camera, and that will be the view going forward. Again, we can edit the animation paths of this set of bolts. And now when we play it, the bolts go into place. If we go back to the beginning, we can see that the camera automatically moves around. After creating the process animation, we can use dynamic collision detection to find any interferences in the animation paths. We can also use dynamic measurements to guarantee the clearances of all the parts in the assembly process. Here's the process animation that we authored before. Now let's check for interferences in the animation paths. We can do that by turning on dynamic collision detection. So let's take a look at one of these paths here. And you can see this is where a bolt is inserted into a plate. Let's go ahead and automatically check for collisions during that animation path. To do that, we're going to turn on dynamic collision detection. So there's a lot of options here. We can check all the parts or just selected parts. We can check for interference or interference plus clearance. We can pay attention to or ignore contact. And we can stop when the interference is found or continue finding other interferences. In this case, let's go ahead and just select a couple of parts to test. Here's one, maybe the washer, the motor, the plate. And now let's go ahead and turn on dynamic collision detection. Now when we play the animation, Studio is automatically checking for interferences at each step. You can see it's found one, an interference between the bolt and the motor. Okay, if we look down at the timeline, we can see we've got some new keyframes on the timeline. In addition to the white keyframes that we authored, there are interference keyframes here. These show us where the interferences are taking place. So you can easily step back and say, okay, that's where an interference was between the bolts and the motor. And if we step back again, that's where the interference began. You can, of course, also scrub to see this information. In addition to performing dynamic interference checking, Studio can also make dynamic measurements. First step is to select the parts that are to be measured. In this case, let's measure the distance between the bolt and the motor. You can also have multiple dynamic measurements. So let's also measure the distance between the bolt and the plate. In both cases, we set the max distance to 100 millimeters. So Studio will only report the distance if it's less than 100 millimeters. Now if we go ahead and play the animation, as soon as the bolt gets within 100 millimeters of either of the parts, Studio automatically reports it. And you can see that this is consistent with the interference results because as you step back through where the bolt interferes with the motor, the measurement becomes 0. So using these two tools, dynamic interference checking and dynamic measurement, you can automatically detect when there's an issue with your animation path or your process animation. XPL Studio allows you to import tools and human models to check the visibility, workability, and safety of the assembly process. We're going to cover these features in a future presentation, but for now, here are some examples using the current model. XPL Studio allows you to add tools to the model and use dynamic collision detection to check for interferences between the tools and the other parts. This enables you to find the right tool for the job. Studio also enables you to add human mannequins to the model. With the mannequins, you can check postures, workability, and visibility. You can also confirm your safety clearances in tight spaces. With XPL Studio, you can easily document any assembly issues with 2D and 3D snapshots, markups, and annotation. Here's the interference problem that we found before. Let's document it so that we can report it back to the designers. The first thing we'll do is create an annotation view. This is a 3D snapshot that we can mark up to show the problem. After creating the view, we can go back and turn off our process animation edit mode. And as you can see, the model goes back to full display. But we've already captured the issue in the 3D annotation view. So now let's add some markups. We can add circles, notes, maybe even suggest a solution. We can also do other kinds of markups like arrows. And we can change their styles. Within the annotation view itself, we can also add comments. And we can add more properties as well. Maybe a checked by, a category, maybe even a checked date. And you can see these can be edited in the edit view here. After you've documented all of the issues as annotation views, go ahead and save the XBL file. Given a saved XBL file, you can use XBL Studio, Lattice 3D Reporter, and other tools to publish reports in several different formats, including Excel, 2D, and 3D. Here is a 3D document template in Excel using Lattice 3D Reporter. To create a report, simply select the XBL file. Lattice 3D Reporter is now generating a 3D Excel document. And here it is. You can see the 3D model embedded entirely within the spreadsheet. Also, down below, you can see the annotation views, which show you all of the issues that we've documented in 3D. Seeing the issues in 3D makes it a lot more clear than just traditional 2D illustration. Also, the designer can just step through each of the individual issues and see the ones that affect only them. Another advantage to having the entire 3D model in Excel is that the designer does not have to open up the CAD system in order to see and understand the issue. They have all the information they need embedded in this one report. When there's a design change, you can use XBL Studio's AutoUpdate function to automatically add all of the validation data to the new version of the model. Here's the next version of the model in XBL Studio. As you can see, when the data was converted from CAD, we got the EBOM, but there was no MBOM or process list. Let's use AutoUpdate to bring in all the work that we did on the previous version of the model. Studio is now going through the parts list and matching the parts from the previous version to current version. And as you can see, it reports all the differences. Yellow shows parts whose properties, position, or structure has changed. Orange shows parts that have been deleted or added between the two versions of the model. When we look at these, we see that the parts numbers are very close. They've just been incremented. So let's go ahead and match those, which tells Studio that they're the same parts despite the fact that the numbers changed. We can verify this by doing a visual shape comparison. This shows the differences in geometry between the two parts. Once we're happy with the match, we can go ahead and finish the update. And now we've added the M-bound and the process list to the new version of the model. Let's take a look at the process animation and see if it's resolved any of the issues that we've reported in the previous version. We play the animation, we can see that, yes, indeed, the bolt no longer conflicts with the motor. We can also verify all of the other issues that we've reported on the previous version of the model and check for any new issues that appeared on the new version.
All right, thank you. Mark, back to you.
All right, thank you very much, Mark. And again, if people would like to submit some questions, we've got some time available to do that. There was one question that came in, what software are we using? So let me just respond to that real quickly. So this was, what Mark was showing was XVL Studio, and that is a Lattice technology product for doing authoring. And the file format is XVL. And XVL is a proprietary format from Lattice Technology. You can convert essentially any CAD file, any major CAD system can be converted into XVL, and it's what we call ultra lightweight. It's about 1% of the original CAD model size, but it retains CAD level accuracy. So this enables you to work with extremely large models that you probably had to in your CAD system have as subassemblies and maybe never were able to bring them together. With XVL, you're able to do that. So for example, Toyota is one of our customers, and they can bring entire models of cars into a single XVL instance for doing this validation work, for doing planning, technical illustrations, et cetera. So the XVL format is real critical. So let's see, Mark, there is a question here. Can I reuse assembly plans for different products?
That's a good question, Mark. The answer is yes. In the presentation here, we showed carrying assembly plans forward into new versions of the same product, but Studio also has the ability to apply assembly plans to different products. In that case, what you would do is you'd first author your assembly instructions, and then you would use Studio to save off those assembly plans as an Excel format. And then in the new product, when it comes in, even if it's totally unrelated, you can then use Studio to import those assembly plans from Excel and then match those up part by part to the new products. So Studio does support essentially product templates or product planning templates by using Excel as the intermediate format. So good question.
Yeah, and let me add one little bit onto that, the whole topic of reuse. So one of our major value propositions with Lattice Technology and Studio is that you're able to start doing this validation and planning work while products are still in design. So this whole notion of reuse that Mark demonstrated allows you to not only reuse the next time you have a new product coming out, it allows you to keep all the work you've been working on while products are still in design, so you can get started earlier. So there was one more question about the CAD formats that we support. So there is a separate product that it's a Lattice technology product that does the conversion. So it takes native, CATIA, NX, SolidWorks, Solid Edge, you name it. If it's a major CAD format, it's supported.
That's right. We actually have a couple of different ways of converting those CAD data. If you have a CAD license, we actually have plugins for most of the CAD systems that'll basically export data directly to XBL. If you don't, we also have an independent converter that can independently read CAD data and convert it to lightweight XBL.
Great. Well, we're drawing close to the bottom of the hour here, so we're going to wrap up. And there's a couple other questions we'll get to and respond to those offline. Someone asked the question about the recording. So yes, you will. Everybody will receive after this. Will probably be tomorrow. We will send you a link to the recording and also the PDF of the book that Mark co-authored, 3D Manufacturing Evolution. So just to wrap up, Lattice Technology offers a suite of tools, and they're all based on this XVL file format, which is ultra lightweight 3D. And as I said before, this lightweight format allows entire assemblies, even extremely large ones, to be brought into a single instance. And from that, you can do authoring, which includes the planning, the validating that Mark went through today, and creating all sorts of technical communications. So if you'd like to learn more about how Lattice can be used in your environment, please just drop us an email and we'll get in touch with you. So with that, Mark, thanks for your time today. Thanks to all of you for joining us, and hope you join our next webinar. Thanks again.
Thanks, everyone.